Hey guys, today's video is going to be about chemical formulas, understanding the difference between atoms, molecules, elements, and compounds, and also counting atoms in chemical formulas. This is an important skill because eventually you will need to know how to do this in order to determine whether or not chemical equations follow the law of conservation of mass. So before we begin, let's just go over some important vocabulary words that we haven't seen before. The first one is chemical formula. This is a shorthand way to describe the number of each element that is present in a compound. The element symbol, which you should already know, is an abbreviation for an element. It contains either one capital letter or a capital and a lowercase letter. And how we write these is extremely important. Um, you need to make sure that when you're writing these formulas that you're writing the element symbol exactly the way it says on the periodic table. Molecule can be an element or a compound. The basic rule to make it a molecule is that it has to contain two or more atoms. Those atoms can be the same or they can be different. A compound is a substance that is made up of two or more different atoms. A subscript is the number written in smaller print, usually below the element, that tells us how many atoms of an element are in that compound. And then the coefficients are large numbers placed in front of the formula to identify how many molecules are present. So we'll look at these five different chemical formulas and decide whether they are atoms or elements, whether they are compounds or molecules, and then what their name is. So looking at the one at the top, O, this is an atom. Okay, and the reason it's an atom is because there's no subscript, so that means there's only one atom of oxygen present. So because there's only one element symbol, this is an element. Okay, so this is an atom of oxygen. That's what this represents, an atom of oxygen. Okay. Now here again, very similar. The only difference now is that we've written this little number here to the bottom right. This is the subscript that we mentioned earlier. And what this does is it tells us that there are two atoms of oxygen. So since there's more than one atom, if we look back at the vocabulary, anything that has more than one atom is a molecule. Now, it's still an element because there's only one um, element symbol present, but it is no longer an atom of oxygen. It is now a molecule of oxygen. Okay, so basically, a good way to kind of think about this is kind of plural. If there's more than one of anything, it's got to be a molecule. Okay. All right. Um, the next one, NaCl. So this is an element symbol. This is an element symbol. And since there are two different elements in this formula, that makes this a molecule, sorry, two atoms in this formula, one atom of sodium, one atom of chlorine. So that makes this a molecule. But this is not an element because there are two different chemical symbols there. So there's an atom of sodium and an atom of chlorine, and they've bonded together to form a new substance. Okay, and that new substance is called sodium chloride. More commonly in everyday language, we use the word salt. Okay, so the next one, H2O2, again, more than one atom. All right, so there's two atoms of hydrogen and two atoms of oxygen. So that makes this a molecule. And because there's more than one different element, this is also a compound. Now, It looks very similar to the formula for water. However, we do have one extra oxygen there, and so that changes the chemical properties of what the substance is. So this substance is not like super water. This substance is called hydrogen peroxide, which most of you probably have in a brown bottle somewhere under a sink in your bathroom. We use it to clean wounds, um, but it is poisonous if we drink it. And then the last one, I know it's probably a little hard to see, um, but this is F2. Let me move out of the way there. So that's F2. So that's a molecule because there's more than one atom of fluorine. Okay. But because there's only one chemical symbol present, that makes this an element. Okay. And so this is fluorine. So I want you to, before we move on, look at what you see on the elements. Okay. So if you look at all the different elements that are present on the screen, what do they all have in common? Okay, they all have one element symbol in the formula. And if you look at the compounds, the two compounds, what did they have in common? They have two different element symbols. Okay, and the difference between atoms and molecules are, if you look at the atom, there's no subscript, so there's one chemical symbol and no subscript. Okay, so remember that the difference between an atom and a molecule is just the number of atoms. Doesn't We're not really concerned about what atoms they are or what elements they are. If there's more than one, it's just a molecule. And then to differentiate between elements and compounds, elements have one chemical symbol, compounds have more than one different chemical symbol. And an easy way to identify it is just counting capital letters. So you'll notice here, only one capital, one capital, one capital, and all of those are elements. But here you see two capital letters and then two capital letters, and so that makes it a compound. So that's kind of an easy, quick way to determine the difference. Okay, so when we're looking at a chemical formula of a substance, and this happens to be the chemical formula for sulfuric acid, um, it's a compound. We should be able to identify that because there's more than one element involved. It's also a molecule. It's definitely a molecule because there's definitely more than one atom present in that formula. Okay, so this is a molecule of sulfuric acid. And we'll talk about what this 3 means here in just a minute. That's the coefficient. So what the coefficient does is it tells us that we have 3 molecules of H2SO4 or sulfuric acid. Okay, and we'll talk about how we use the coefficient in counting of atoms here in just a second. So these two small numbers down at the bottom again are subscripts, and these numbers again apply only to the element that they're next to. So this 2 only applies to the hydrogen. Sulfur right here does not have a subscript, so that means there's only one sulfur atom. And then the 4 here next to the O only applies to the oxygens. So there's 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. And again, these are the chemical symbols for those 3 elements. So in this formula, there are 3 different elements: hydrogen, sulfur, and oxygen. There are 2 hydrogens, 1 sulfur, 4 oxygens. All right. And then again, on the next slide, we'll talk about how we incorporate the coefficient. So as we go through this practice of learning how to count atoms, there's kind of a step-by-step process that I believe helps. Some students can look at it and just do it without writing things down. Some students need to be a little bit more methodical or purposeful as they're learning how to do this. So I encourage you to start this process as you're learning how to do this, taking it slow and going through the process that you see on the next slide. And then the better you get at it, the quicker it'll come to you. But again, when we start, we want to make sure that we're doing it methodically until we get the hang of it. So the first step is to find the element symbols, looking for capital letters to identify the elements, and then list the elements. Step 2 is to look for subscripts to determine how many atoms of each element are present. If there's no subscript, that means there's only one atom. And then you're going to add the total number of atoms together and then look for the coefficient if present. If it is present, then you're going to multiply each element total by the subscript. So let's go ahead and use this same formula to practice. Okay, so you notice that I've covered up this coefficient for now because we want to ignore it at first. We'll come back to the coefficient here in just a minute. So remember that step 1 was to list the elements present. So the elements present in this chemical formula are hydrogen, sulfur, and oxygen. Now, step 2 was to look for subscripts. Okay, so does hydrogen have a subscript? Yes, it does. It has a 2. Okay, does sulfur have a subscript? No, it doesn't. So there's only 1. And then does oxygen have a subscript? Yes, it does. So there are 4. So right now, without the coefficient, okay, we add those 3 numbers together to get a total number of atoms in a molecule of sulfuric acid at 7. Okay. But now, if there is a coefficient present, now is where we kind of deal with that coefficient. And we can deal with it 2 ways, depending on what the question is asking you. But we need to understand that that coefficient applies to every single element that's inside the formula. Okay. So with that 3, we have to multiply each one of the elements by 3. Okay. So it becomes 3 times 2, 3 times 1, and 3 times 4. Okay. And so when we do that, we get 6 hydrogens, 3 sulfurs, and now 12 oxygens total. Okay. Now, if we add those numbers up, we get 21. And also, if you come down here and just take the total and multiply it times 3, you're going to come up with the same answer as you did if we did it this way. The reason I show it to you this way is because you may have a question on a test, on the STAR test, that says how many atoms of hydrogen are present in this formula, and you can't ignore this. Okay. So you have to be able to multiply each individual element by the coefficient. Okay. So 3 times 2 is 6 hydrogens, 3 times 1 is 3 sulfurs, and 3 times 4 is 12 oxygens. So again, if we add those all up, we come to 21. If it just asked for like the total number, then you could just add up all the elements in the formula without the coefficient and then multiply that times 3. So really it depends on what the question is asking. And so that's why I went through the process both ways. Okay, let's do one more practice. Oh, yeah, magic. So sometimes you're going to have to deal with parentheses. Okay, and very similar in math, where when you have parentheses, you kind of have to focus on the parentheses first. So if you'll notice, inside the parentheses, we have one O and one H, but outside the parentheses, we have this subscript here. So we have to that subscript deals with only those elements that are inside the parentheses. Okay. It does not apply to the magnesium. It only applies to those elements that are inside the parentheses. So again, step by step, the first thing we need to do is list the elements. And that's magnesium right here, Mg, oxygen, and hydrogen. Okay. And then there's no coefficient here, so we don't have to worry about dealing with a coefficient right now. But we then count again how many we have. So magnesium, what we see is just one of each And then we have to deal with this subscript here. So again, that subscript only deals with these two. Okay. So we only have to multiply these two times that subscript. Notice we didn't have to multiply the magnesium by that because it's not inside the parentheses. Okay. So then we look at the total. Again, magnesium is 1. Now we have 2 oxygens and 2 hydrogens. So if we add these 3 letters up or numbers up, we get a total of 5. Okay. So remember with parentheses, what you see inside the parentheses, if there is a subscript after that, that applies to both of those in the formula. Okay. All right, guys. So hopefully this helps. I know we kind of went through some things last week rather quickly, but I wanted to kind of do this step by step for you all to kind of help you understand how we count atoms in formulas. And these are skills, of course, that you're going to need for the majority of this week and moving forward into chemistry when we get into the law of conservation of mass and determining whether or not chemical equations are balanced or unbalanced and or follow the law of conservation of mass. As always, if you have any questions, please let me know. Send me an email and good luck, guys.